Good day to all. In today's class, we'll discuss the control valve and its flow characteristics briefly. So at the end of this presentation, you'll have a short quiz to refresh what we have learned from today's session. Let's start with what is control valve, and we'll discuss its main characteristics later. Control valve, it's kind of the valve. It's used to control the fluid flow by varying the size of flow passage, as it's directed by a signal from controller. We learned in previous sessions that controller is a part of the overall control scheme, and the control valve it's one of the major equipment that's used in the control loops. So it will enable for us to directly control the flow rate and its consequential control of process quantities. When we say the process quantities, we mainly consider the pressure, temperature, level, and etc. So we'll continue with the control valve flow characteristics. Control valve has three flow characteristics. First of all, the linear, then equal percentage, quick opening, or with the other name, you can call it on or off services. If we see how they are used, how they are regulated, and where they should be matched to the application, so we'll discuss it now. First of all, let's look at this diagram first. In this graph, on the y-axis, we have the CV percentage. On the x-axis, we have the valve opening percentage. This CV, it's very important for the control valve sizing as well, which we'll be discussing in the next session. So the valve opening, it depends on the CV, and based on these differences, we have quick opening, linear, and equal percentage types. Let's start with, first of all, the linear valves. Also keep in mind that we have here the delta P, pressure drop, it is constant. Linear valve, when your control valve is labeled as the linear, it means that its inherent flow characteristics, it could be represented by a straight line, y equal to k multiplied by x. This k, it depends on this curve. So it's represented by a straight line, and on this plot, as you can see, it depends on valve opening and CV percentages. And it's required to be considered at ideal cases because your delta P is constant. The flow rate can be varied with percentage of the opening of the control valve. For example, if you want to open your control valve for 20%, so you'll come to this point and you will see that your CV is also changing for the 20%. If you want to open like the 80%, so you can see that on this curve, your diagram, the CV, it will also be opened and changed for the 80%. So this is called the linear characteristics. So the linear valves, in general, they are preferred in situations where you have the consistent and predictable flow control. So in this case, so they could be used in the pressure control systems and some precise flow adjustments, and sometimes even the level control valves as well. Now let's continue with the equal percentage one. So equal percentage characteristics, we say that the control valve, it is equal percentage when it has this shape. So if an equal increment of the valve travel, like this, it is the same, produce the same equivalent change in the CV at ideal conditions, as I mentioned before. So if I summarize from the equal percentage, it means that in an equal percentage valve, each increment in valve movement, it results into the same increase relative to the previous flow rate. So that when your valve is slightly open, your flow changes are minimal, but as the valve it opens further, like from the 20 to 80, let's say, your flow rate increases rapidly. We can see it from this example. If I change my color of the pen, so here you can see for the 20%, you have like around the 5% somewhere here. So if you go to the 40%, it will be also increase the same percentage. If you come to the 80%, already 2 times, and from here it's the 4 times. So your the flow rate, the CV will be changed more than 40%. It will be somewhere here. And equal percentage valves, they are more applied if you have the wide operating range for the pressure variations that you can see it here, and where both low and high flow rates needs to be carefully managed. Now let's come to the last part, which is the on-off valves. I'll change the color again, the on-off valves. For the on-off valves, we have mainly the quick opening that we call it with the other name, or fast opening characteristic, let's say. For the quick opening characteristics, they have a flat disc instead of contoured valve plug, like this and this one, linear and equal percentage. They have the valve plug shape is different, but for the on-off valve, it has the flat disc. So its flow, let's say the CV dependency, it will increase rapidly to its maximum flow somewhere here at 100%, as you can see, with a minimum initial valve opening. As you can see from this graph, if I change it, let's say from the 20%, in the quick opening, you have already around the 65, 68 percentage, the flow rate changed. If I open it around the 60%, it is already around the 90%, the flow rate will be changed. So so we can use this quick opening valves in summary, let's say, if they have this on-off characteristic, the majority of the flow change occurs at the beginning in the initial change, initial valve movement. So nearly maximum flow is achieved with minimum stem movement. So stem is a part of the valve mechanical parts. And the application, when we come to the application, so they are mainly used for, you have the rapid access for the high flow rates, such as on-off control systems, and they are not actually well suited for precise control in intermediate positions, intermediate systems. So we mainly gave the information about the quick opening, linear and equal percentage. If I summarize again, so linear, as you can see, it has the linear characteristics like this. Y is equal to kx. You can keep in mind like this. Equal percentage, they have the same equal percentage increment in valve opening and in the CV positions. Quick opening, it requires the minimum change but maximum flow change. Now let's come to the next part, which is the quiz time already. We finalize mainly, so what are the typical characteristics of the control valve and what is control valve in general. Now we'll check what you have learned from this, let's say the short presentation. And before I release the answers to the next slide, so you can take your time, stop the video and check your results as well. For the question 1, I want you to tell me, so which flow characteristics is it given on this curve. So you can see it's a bit different shape. In the question 2, control valves can regulate the followings: flow, pressure, viscosity, and temperature. I mentioned them in the very first slide when we discussed the main purpose of the control valves. And the third question, it's true or false. It says that equal percentage valves are used in applications that require rapid access to high flow rates, and they are not well suited for precise control in intermediate positions. So at this stage, you can stop your video, or if you already answered all questions, now you can move to the next slide. Now answers to our quizzes. The first question, which was in this shape, if you remember, the quick opening. It has the same shape, percent of the rated valve, and percent of the maximum flow, which depends on the CV and the valve travel. So it's the same shape, and this is the quick opening. This is the answer to our first question. The second question, it might be a bit tricky because the right answer here is the flow, pressure, and temperature. Sometimes most of the students confuse a bit also the temperature, but the valves, control valves, could also control the temperature as well, especially temperature regulators and temperature control valves. They are sometimes referred as the TCVs, like an acronym. They are designed to control the temperature of process by controlling the thermal fluid pressure or flow in compressors, tank jackets, in reactors, heating coils, and etc. In the third question, I told you that so the equal percentage valves are used in application where require the rapid access, but it was false. It's purely false because not the equal percentage. We mentioned that on-off quick opening valves are used in such applications, and also they are not well suited for precise control in intermediate positions and systems. So this is mainly from the quiz answers. I hope they were quite easy and easy to answer as well after the short presentation. So that's all for today. We finished the today's session and I hope you learned something new and enjoyed it. In the next session, we'll discuss the control of sizing. Thanks. See you.